Hello everyone, welcome to Big By Physics, and in today's video I'll be discussing a problem from 200 puzzling problems in physics, of course by Peter Nadick and Honiek Riley. And this question is problem 60, and this is based on the topic of rotational dynamics. So pause the video. Well, I'm explaining the two cases. In first case, the groove is something in form of a square. Okay, this is a frictionless groove. It is frictionless, and this groove is a little bit in form of a square. And in second case, it has sufficient friction to prevent slipping. Means mu is very high. You can say it like this: mu is very high. Okay, so this is the second case. In first case, it is saying that it is a square like groove or a rectangular like groove, whatever you take. Okay, and this is frictionless. A rod is about to fall about this groove, and you have to tell me the angle at which it will leave the contact. And in second case, it is saying that it is a nearly spherical groove with a very high curvature or a very small radius. Okay, this radius r, okay, is very negligible as compared to the dimensions of the rod, so it will almost execute a pure rotation about this as the pivot. Okay, so this is the second case, and in this case you have to tell me the same thing, that is angle at which it will lose contact. Pause the video, spend few minutes to try this problem. Okay, so let's get started. The question says that a uniform rod is placed on one edge of the table and nearly vertical position. These are the two cases I already explained. So you have to basically find the angle of contact. First, I'll be discussing about part B. Okay. Well, there's some reason you can understand later why I'm discussing part B at first. Part B, you must have done in Irodov too, that if this is my rod, it will leave the contact as soon as mg cos theta. That is a normal. I'm equating the force along the radial direction. So this is theta. So mg cos theta, and what will be radial acceleration? It will be centripetal, which will be m omega square L by 2. Can we write here using work energy that mg L by 2 1 minus cos theta is equals to half m L square by third omega square. So I can say m omega square L by 2 is equal to um, m omega square L by 2 is equals to 3g by 3 mg by 2 1 minus cos theta. So this is my centripetal acceleration into mass. Basically, this will give F is equals to ma. So I can say what is mg cos theta is equals to 3gm by 2 1 minus cos theta, but it will leave the contact just the same as the Rodov question you might have seen probably in somewhat around 200 or 300. Okay, it's from the rotational mechanics only. That's the procedure which is applied here. Just equate the radial force with the radial acceleration, and you'll get cos theta is equals to 3 by 5. This implies angle equals to 53 degrees. Okay, I hope you got it. So part B was relatively easy, you can say, because you just needed to apply some formula. Now what about part A? Part A is same or different to B. That is, angle at which it will leave is 53 degree or something else. Okay. Okay, for part A, I am giving one thing, that angle at which it will leave with respect to the vertical. So with respect to vertical is given as cos inverse x by y, where GCD or the greatest common divisor of x comma y is given as 1. You have to report the value of x plus y. Okay, pause the video, give it a try. Okay, so getting started with part A. Part A is actually you have to apply your brain a little bit. That's it. So it will be the situation. Let it this be the situation when the rod is just about to fall, and it makes angle theta. Then the wall will provide two forces. It will be first normal along the x direction and normal along the y direction. Okay. So this is the basically the case. So tell me one thing: if either of nx or ny disappears, let's say either of nx or ny disappears, then can we confirm that the rod will fall? This implies the rod falls. Yeah, of course. Assume that nx has disappeared, means the rod will be accelerating in this direction, so it will slip and skid outwards. If ny is lost, then again it can be regained, but if nx is lost, then it will obviously skid. It cannot come back to its original position. So one thing we can say that if nx is disappears, then the rod will fall, right? So now, dealing with the dynamics, this is the rod, and suppose this is my center of mass. This will have one tangential acceleration at and one radial acceleration ar. Okay, so can you tell me what will be the acceleration along the x direction? It will be nx by m, will be acceleration along x direction. Similarly, can I write at and all those in terms of that? At by L by 2 will give me the angular acceleration into 1 by third ml square. This is I alpha is equals to tau. What is tau? Mg L by 2 sin theta. So I can say At is equals to 3g by 4 sin theta. Yeah, this is one of the equations we require. And second thing, we already derived that omega square is equals to 3g by L 1 minus cos theta. So I can say a ddl to be omega square L by 2, which will come out to be 3g by 2 1 minus cos theta. And ax can be written as um, ax can be written as at cos theta minus ar sin theta. So at cos theta minus ar sin theta. Just simplify the equations. What is 80 cos theta? 80 cos theta will come out to be 3g by 4 sin theta cos theta. 3g by 4 sin theta cos theta. What is AR sin theta? 3g by 4 sin theta, 3g by 2 sin theta into 1 minus cos theta. Taking out sin theta 3g by 2, 3g by 4 sin theta common out, then we get 3g by 4 sin theta cos theta minus 2 plus 2 cos theta. So you will get nx by m is equals to 3g by 4 sin theta into 3 cos theta minus 2. Now tell me one thing. Okay, first of all, cross multiplying m both sides. Tell me one thing. If theta is equals to 0, nx is positive, and we know cos theta is a decreasing function. So after theta, if theta is greater than cos inverse 2 by third, then I can say that nx turns out to be negative or less than equal to 0. If theta greater than equal to cos inverse 2 by third, nx becomes less than equals to 0. This means the rod slips. And one thing you might know that cos inverse 2 by third is 48 degrees almost, which is less than the previous value we got. Okay, so I can say that the rod slips when the theta is greater than 48 degrees, or when theta reaches 48 degree, it would not be stable and it will just skid away. So that's the answer. One thing you must know that both the cases are not same. They may ask you in the multiple choice type that is the angle in both the case same? Is the angle in both the case different? They may give you the cos inverse or 2 by third value, which equals 48 degrees, and cos inverse 3 by 5, that is 53 degrees, or sin inverse 4 by 5. They may give you whatever, and you have to report the difference in the values. So JEE may frame this question in many ways. You have to be ready with it. So that's all for today. Thank you and have a nice day.